Hey guys, today we are going to be looking at vertex form of quadratics. We're going to answer the question, what is vertex form of a quadratic and how do I graph quadratics in vertex form? So far with quadratics, we have looked at standard form, which is y equals ax squared plus bx plus c. We are introducing a new form today, vertex form, y equals a times x minus h squared plus k. And as you can tell from the name of it, it's going to tell us some different information than standard form. So I have put vertex form into Desmos, and we're going to see if we can determine what a, h, and k do to the parabola. So right now we have the quadratic parent function. Let's look at what happens when I make a bigger. It gets skinnier. So if a is bigger than 1, then it's going to get skinnier. Okay, let's look at what happens when I make a less than 1, but the absolute value of it is less than 1. So I'm not going to make it negative yet. It looks like I get wider. So if I'm multiplying by a number bigger than 1, skinnier. If I'm multiplying by a number less than 1, wider. And then let's look at what happens when I make it negative. It flips over the x-axis, so it's a reflection. So the number in front of the parentheses is going to determine the shape and the way that it is facing. All right, let's look at what is happening with h now. But first thing I need you to observe is that in vertex form, we have a minus h. So the first thing I'm going to do is make h on the slider negative, but that's going to be minus a negative h, which is really going to be a plus h, okay? So we're going to look at this plus h first, and the way I'm going to get that plus h is by doing minus a negative h. So when I add h, when h is positive, it's going to move left. And then when I subtract h, that means h itself would be positive on this slider and I move to the right. Okay, so horizontal translations are opposite of what you would think because of that subtraction sign. If we add h, we are moving to the left. And then if we subtract h, we are moving to the right. And then let's look at k. So if I add k, I am moving up. And then if I subtract k, I'm moving down. And I don't have to worry about the opposite signs with that one because it's just the plus k. All right, so those are all of the different transformations. And since h and k were shifting the vertex left, right, up, or down, the vertex is hk. And then the axis of symmetry is x equals h because the h controls how much we shift left or right. So let's go ahead and look at this right here. I have the parent function graphed, and then here is the transformed function. So the first thing that I notice is that this transformed function is skinnier since I had a number that I was multiplying that was greater than 1. So the first thing is that it is skinnier. We can say it is a vertical stretch by a factor of 2. Okay, then remember the number inside the parentheses controls the left or the right, and that would be minus 3. So it's the opposite of what we would think. It would be right 3, which it looks like this parabola did move to the right. So that means our vertex is going to have an x value of 3, which we can see, and then the axis of symmetry shifted from x equals 0 to x equals 3. And then the last part I see that's going to cause a transformation is that plus 1, which means I moved up 1, which I can see on the vertex. So the vertex is 3, 1. So there's how to look at the transformations in vertex form. You look at the number in front to determine the shape. That made it skinnier. The number inside the parentheses shifts it left or right, and it's going to be opposite of what you would think. And the number outside the parentheses will shift it up or down. Another thing that we are going to do today is convert from vertex form to standard form. So the first thing that we need to do is multiply the x minus h squared. And remember, we do not just distribute that squared. That means x minus h times x minus h. So we can either use the box or FOIL, or if you remember that perfect square trinomial pattern, you can use that too. Make sure you're not just distributing the square though. Use one of the methods that we have learned to multiply. Then after we multiply this, you're going to distribute the a to that product, and then you will combine like terms with k. So in this problem right here, I need to convert this to standard form. And let me write the problem. It was y equals 2 times x minus 3 squared plus 1. Okay, so the first thing I need to do is the x minus 3 squared. So I'm going to use FOIL for this. You can use the box too. So first times the first is x squared, outer times outer is negative 3x, inner times inner is negative 3x, and then last times last is positive 9. And I combine like terms and get x squared minus 6x minus 9. So this right here becomes x squared minus 6x minus 9. Everything else is staying the same. So my new equation is y equals 2 times x squared minus 6x minus 9 plus 1. Now I need to distribute this 2 to what I got when I FOILed. So it'll be y equals 2 times x squared is 2x squared, 2 times negative 6x is negative 12x, and 2 times negative 9 is negative 18, and then plus 1. And then my last step is just to combine like terms with those constants. So the final answer in standard form is y equals 2x squared minus 12x minus 17, because negative 18 plus 1 is 17. Okay, I'm going to show you my favorite way to check this. So I'm going to graph the original problem they gave us to in Vertex form, 2 times x minus 3 squared plus 1. And then when I graph the standard form, it should create the same exact function. 2x squared minus 12x minus 17. Oh, which it does not, so I must have done something incorrectly. Let's see if I can figure out where I went wrong. I see it. Negative 3 times negative 3 is positive 9, which I wrote here, but then for some reason I just put negative 9. So that's going to change this to a positive 9. That'll change this to a positive 18. So this number right here should have been positive 19. So let me change this to a positive 19. There we go. Now it's the same function. Okay, so that is why you want to double check your work. Okay, let's look at number 1. I'm going to start with the transformations, and then I will determine the axis of symmetry in Vertex, and then we will practice converting it to standard form. So the first thing that I notice is this 3 right here. That means that my parabola is going to be skinnier. It's a vertical stretch by a factor of 3. Okay, then I have inside the parentheses, I'm subtracting 1. So that means I'm going to go right 1. So my axis of symmetry is x equals 1 since it shifted to the right 1. And then the x value of my vertex is 1. And then I have this minus 5, so that means I went down 5. So the y value of my vertex is negative 5. Okay, now I'm going to convert this to standard form. So the first thing that I need to do is multiply x minus 1 squared. This time I'm going to use the box to do that. You can still use FOIL like I did last time. Okay, so x times x squared, or x times x is x squared. x times negative 1 is negative 1x. Negative 1 times x is negative 1x. And negative 1 times negative 1 is 1. And then I combine like terms, and I get x squared minus 2x minus 5. Or minus, I was looking at the minus 5 from up here. Minus 2x plus 1. Okay, now I'm going to replace that with the product I just found, and I'll distribute the 3 to it. So it'll be y equals 3 times the product I just got, x squared minus 2x plus 1 minus 5. So now let's distribute, and we get y equals 3x squared minus 6x plus 3 minus 5. And then let's combine like terms, and I get y equals 3x squared minus 6x minus 2. So let's double check that I converted correctly, and I'm going to check visually on the graph that all of the transformations happened that I wrote down. So let's put the vertex form y equals 3 parentheses x minus 1 squared minus 5. Okay, so it does look skinnier. Looks like I did go right and down with my vertex, and let's make sure the vertex is 1, negative 5 like I thought. Yes. So we got all of the transformations and axis of symmetry and vertex correct. Let's make sure that I converted this to standard form correctly now. 3x squared minus 6x minus 2. Creates the same parabola, so I'm good. All right, let's look at number 2. So I have a negative sign in front of my parentheses, which means that I have a reflection over the x-axis. There's no number, so I did not make the parabola any skinnier or any wider. And then I do have some addition, so I shifted. This plus 2 inside the parentheses means that I moved left 2. So my axis of symmetry is x equals negative 2, and then the vertex is negative 2 for the x value. Remember, since it's minus h in vertex form, it's opposite sign. And then this plus 6 outside the parenthesis means that I went up 6, so the y value of the vertex is 6. Okay, now I need to convert this to standard form, so let's start by multiplying the x plus 2 squared. And I'm going to use the box again. X plus 2 times x plus 2 would be x squared. That's 2x, 2x, and 4. So I get x squared plus 4x after I combine like terms plus 4. So now I'm going to replace this with this product. I need to make sure I keep that negative sign out front of the parenthesis because I'm going to have to distribute that negative. So it'll be y equals negative parentheses x squared plus 4x plus 4 plus 6. Okay, so now I need to distribute this negative. I'm just changing the signs of everything inside the parentheses. You could think of it as distributing a negative 1 if you wanted. Negative times x squared is negative x squared. Negative times 4x is negative 4x. And negative times 4 is negative 4, and then plus 6. And now I need to combine like terms. So I get y equals negative x squared minus 4x plus 2. So y equals negative x squared minus 4x plus 2. And now I'm going to make sure that I graphed this, or I converted correctly and did my transformations correctly. So I'm going to put the vertex form in Desmos, negative parentheses x plus 2 squared plus 6. Okay, looks like I got that reflection, and my vertex did go left and up. And the vertex is negative 2, 6 like I thought. Now let me graph the standard form that I converted to and make sure that it makes the same parabola, negative x squared minus 4x plus 2. It does, so we did that correctly. Okay, last one, I am doing the same thing, but I also am going to graph the parabola. So why don't we determine the transformations, and then that will help us figure out the axis of symmetry vertex, and then we can convert to standard form, and then we will graph it over here. So let's start with transformations. So I see a negative sign, so that means that I have a reflection going on. And then I also have this 1/2. So I'm multiplying by a number less than 1, so that means my parabola is going to get wider. And then I have this minus 3, so that means that inside the parentheses, so that means I go right 3. So my axis of symmetry is x equals 3, and the vertex is 3 for the x value. And then the minus 2 outside the parentheses means down 2. So negative 2 for the y value. Okay, now I want to convert to standard form, so I'm going to multiply the x minus 3 squared. I'm going to use the box to do that. X minus 3 times x minus 3. So x times x is x squared. X times negative 3 is negative 3x. X times negative 3 is negative 3x. And negative 3 times negative 3 is positive 9. So after I combine like terms for that product, I get x squared minus 6x plus 9. So now I need to replace this with the product I just got, and I'm going to distribute a negative 1/2 to it. So it'll be y equals negative 1/2 times x squared minus 6x plus 9, and then minus 2. Okay, now I'm going to distribute the 1/2, negative 1/2. So negative 1/2 times x squared is negative 1/2 x squared. Negative 1/2 times negative 6x is positive 3x. And then negative 1/2 times positive 9 is negative 9/2. And instead of just writing minus 2, I know I'm going to combine it with this number. So I'm going to change this minus 2 to a minus 4/2 to get those common denominators. So now it's easier to combine. And I get y equals negative 1/2 x squared plus 3x minus 9 minus 4 is 13, and then keep that common denominator. So y equals negative 1/2 x squared plus 3x minus 13/2 for standard form. So now I need to make a table for this and graph it. So vertex is going to go in the middle of my table at 3, negative 2. And I'm going to go ahead and plot that, 3, negative 2, and my axis of symmetry goes in between that. Okay, now I'm going to put the vertex form into the calculator, and I can get some other points for my table. So negative 1/2 parentheses x minus 3 squared minus 2. Okay, so there's the vertex at 3, negative 2. I did that correctly. And I want 3, negative 2 to be in the middle of my table. So that means I'm going to have 2 and 1 for x values right below it, and 4 and 5 above it. So I'm going to go ahead and change my table to match that so that the vertex is right in the middle. Okay, and now I have some other points. It looks like around the vertex I have the point 2, negative 2.5 and 4, negative 2.5. And then I have negative 4 and negative 4. So I'm going to go up or down to negative 2.5 right there. And then I'm going to plot the point 1, negative 4, and 5, negative 4. So there's the parabola. And looks like our transformations are correct. That is reflected, wider, we went right and down. The last thing that I need to check is that I converted the standard form correctly. So I'm going to put the standard form that I got into Desmos and make sure it creates that same parabola. And it does, so we did that correctly too.